Chapter 25 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, a Geographical Reader, by Harold Wellman Fairbanks. Chapter 25. Gold and Gold Mining. Gold derives its value partly from its purchasing power, partly from those properties which make it serviceable in the arts, and partly from its beauty. The high esteem in which gold money is held is as much the result of its comparative rarity as of its physical properties. Among nearly all the nations of the world it has been agreed upon as a standard of exchange. Gold has one disadvantage as a medium of exchange. It is rather too soft to wear well. But this difficulty is overcome by alloying the gold with another mineral of nearly the same color, copper for instance. In order that we may understand better the position which gold occupies in the arts and trades of the world, let us compare it with other metals, and first with platinum. This mineral is far less abundant and has many properties which make it valuable in the arts. Like gold, platinum is malleable and ductile and does not tarnish in the air, but it differs from gold in not being easily fusible, so that it is used in the laboratory for crucibles. The steel gray color of platinum is, however, so much less attractive than the yellow of gold that it is not used for ornamental purposes. An effort was made at one time by Russia, where a comparatively large amount of platinum is found, to coin this metal into money, but its continued use was not found practicable because of its changing price in the markets of the world. If the leading nations would agree upon a fixed value for platinum, it might be used like gold as a medium of exchange. Silver is brighter and more attractive than platinum, but is of little use in the laboratory. It has been found in recent years to be so much more abundant than gold that its value has decreased greatly as a commercial article. In our country, when coined, it has, like paper money, been given a value equal to gold. The diamond has a value far exceeding that of gold, but this value is dependent almost wholly upon its ornamental properties, although the brilliant stone is also useful as an abrasive and cutting agent. From these facts it is evident that gold, because of its rarity, its physical properties, and its beauty, combines a larger number of desirable characteristics than any other mineral. Gold can be found in very small quantities nearly everywhere. It is present in all the rocks and also in sea water. The gold that is distributed in this manner is of no value to us, for it would cost many times as much to obtain it as it is worth. Nature has, however, concentrated it for us in some places. In portions of the world where the crust has been folded and broken, there are veins of quartz extending in long, narrow, and irregular sheets through the rocks. This quartz is the home of the gold, and it is usually found in hilly or mountainous regions. Do not mistake the yellow iron pyrites for gold. Pyrites is brittle, while gold is malleable. You can hammer a little grain of gold into a thin sheet. Do not make the mistake, either, of thinking that the shining yellow scales of mica which you can see in the sand in the bottom of a clear stream are gold. These yellow minerals that look like gold have been called fool's gold, because people have sometimes been utterly deceived by them. Upon the Pacific slope minerals are now being deposited in some of the openings of the rocks from which hot springs issue. A study of these springs has led to the opinion that the gold-bearing quartz veins were formed in a similar manner, but at a very remote time in the past. The milky or glassy quartz, which is so hard that you cannot scratch it with the point of your knife, the little grains of pale yellow iron pyrites, and the grains and threads of gold scattered through the quartz were at one time in solution in water. This water came from some region far down in the earth, farther than we can ever reach with the deepest shafts, and there, where it is very hot and the pressure is great, The water dissolved the little particles of gold and other minerals from the rocks, and then, gathering them up, bore them along toward the surface, depositing them as solid particles again in the form of veins in the fissures through which the stream was passing. As the rocks upon the surface decay and the crumbling material is carried away by running water, the gold, being very heavy, washes down the hillsides and is at last gathered in the gulches. This fact explains why we find gold both in veins and in the gravel of the streams. Getting gold from the veins is called quartz mining. Washing it from the gravel is called placer mining, and if the gravel is deep and a powerful stream of water is required, the work is called hydraulic mining. Every one has heard of the Mother Lode of California. Every miner wishes that his mine were upon this famous lode, which is made up of a large number of quartz veins extending along the western slope of the Sierra Nevada mountains, and is marked by hundreds of important mines. A line of towns marks the course of the Mother Lode for over 100 miles. They are almost entirely supported by the gold which the lode supplies. The gold first discovered in California was placer gold. After the miners had worked over the stream gravels and had secured all that they could in that way, they began to search for the home of the gold. It could not always have been in the creek beds, and the miners were correct in thinking that it must have been washed from some other place. Gold was so frequently found in pieces of loose or float quartz that this fact finally turned their attention to the quartz veins, which were numerous upon the mountain slopes. Then came the discovery of the series of great quartz veins now known as the Mother Lode. When the miners first found the quartz flecked with gold, they used the simplest means for separating the two substances. If the quartz was very rich in gold, it was pounded and ground fine in a hand mortar. Then the lighter quartz was washed away and the gold left. The miners also made use of the Mexican arrastra. This is a very crude apparatus, and is employed even now by miners who cannot afford to procure a stamp mill. To build the arrastra, a circular depression 10 or 12 feet wide and a foot or more deep is made in the ground. This depression is lined with stone, which forms a hard bottom or floor. 4 bars extend outward from an upright post placed in the middle of the floor, and a large flat stone is fastened to the end of each bar by means of a rope. A horse is hitched to one of the bars, which is purposely left longer than the others. The ore is thrown into the arrastra, and water is admitted a little at a time. As the horse is driven around, the stones are dragged over the circular depression, crushing the ore and setting free the gold. This way of separating the gold was too slow, and in a short time the stamp mill was invented. It has grown from a very simple affair into the great mill which crushes hundreds of tons of ore in a day. The iron stamps each weigh nearly half a ton. They are raised by powerful machinery and allowed to drop into succession upon the ore, which is gradually fed under them. The stamps crush the ore to a fine sand more easily and rapidly than could be done by any other method. Water is kept running over the ore, and as fast as it is crushed sufficiently fine for the particles to pass through a wire screen, the water with which they are mixed is allowed to flow over large plates of copper, which have been coated with quicksilver. The latter mineral has an attraction for gold, and so catches and holds most of the particles, no matter how small they are. The compound of gold and quicksilver is a soft white substance known as amalgam, utterly unlike either metal. When the amalgam is subjected to heat, the quicksilver is driven off in the form of a vapor, and the gold is left pure. The quicksilver vapor is condensed in a cool chamber and is used again. The iron pyrites in the ore contains gold which cannot be separated by the crushing process, and a machine called a concentrator has been invented to save this also. After passing over the copper plates, the crushed rock and pyrites are washed upon a broad flat surface, which is moving in such a way that the lighter rock waste is carried away by the water. The pyrites now appears as a dark, heavy sand. This sand is placed in a roasting furnace, where the sulfur is driven off and the gold and iron are left together. Now the gold is dissolved by means of chlorine gas, with which it unites in a compound called gold chloride. From this compound the metallic gold is easily separated. All this may seem a complicated process, but it is carried through so cheaply that the ore which contains only $2 or $3 to the ton can be profitably worked. Not all the quartz veins carry gold. There are many in which not a single speck of the precious metal can be found. Gold usually prefers the society of quartz to that of other substances, for minerals, like people, seem to have their likes and dislikes. Along the Mother Lode, however, gold is sometimes found in little bunches and stringers scattered through slate. In such cases the slate is mined and sent to the mill. Some miners devote themselves to pocket mining. They trace the little streams in the rock, and where two streams cross they sometimes find what they call a pocket. This is a mass of nearly pure gold of irregular shape, varying from a few dollars to thousands of dollars in value. This kind of mining is very uncertain in its results, for a man may make hundreds of dollars in one day and then not find anything more for months. The western slope of the Sierra Nevada mountains was once covered with the camps of thousands of placer miners. Piles of boulders and gravel are scattered along the creeks where the eager workers took out millions of dollars' worth of gold dust and nuggets. Now many of the streams and gulches are entirely deserted, but in other places where the quartz veins outcrop there are scores of stamp mills at work night and day, pounding out the gold. Some of the mines have been sunk more than a half-mile into the earth, and the gold is still as abundant as ever. In some portions of the mountains hydraulic mining is more common than quartz mining. Years ago many of the rivers occupied different channels from their present ones. The gravels of these old channels in the Sierra Nevada mountains and in other parts of the West where gold-bearing veins occur are rich in gold. In these channels the gold is so deeply buried that it cannot usually be obtained by means of pick and shovel. In order that the overlying gravel may be removed as cheaply as possible, water is supplied by means of ditches, often many miles long. From some nearby hill the stream is conducted down to the mine in strong iron pipes. It thus acquires a great force, and when directed against a gravel bank rapidly washes it away. Torrents of water-bearing boulders, gravel, and sand, together with the particles of gold, are turned into sluice boxes lined at the bottom with quicksilver. This metal catches the gold and forms an amalgam as it does in the quartz mills. End of chapter 25. Chapter 26 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, a Geographical Reader, by Harold Wellman Fairbanks. Chapter 26. Copper Mining. There is a city hidden away in a narrow cañon in the extreme southern portion of Arizona which is supported solely by a copper mine. The cañon lies upon the southern slope of a range of mountains, and from its mouth one can look far off to the south across the desert plains and mountains of Mexico. This city has an elevation of more than a mile above the sea, and the cañon in which it is situated is so narrow and steep-walled that you can almost jump down from one street upon the roofs of the houses along the street below. Stairways, instead of walks, lead up the hillsides from the main street in the bottom of the cañon. You might well wonder at the position of the city, and think that out of all the waste land in this region a better place might have been selected for its location. But cities grow where people gather, and people do not come to live in the desert unless there is an important work to be done there. A party of prospectors who were searching carefully over the mountains found several mineral veins with green copper strains crossing this cañon and outcropping in the adjacent hills. Claims were staked out and recorded at the nearest land office. Then shafts and tunnels were opened, and the miners became confident from the rich character of the ore that an important copper mine might be developed. Supplies were brought across the desert with teams, and cabins were built in the lonely cañon. Then an enterprising man started a store. As the mine was opened farther, its importance was better understood. There was a call for more miners, and the town grew larger. The houses clustered about the mine, the center of all the activities. At last a railroad was built, and the town became a city, with narrow, winding streets occupying the winding cañon, while tier upon tier of houses crept up the sides of the cañon, which formerly had been covered only by growths of cactus and other plants of the desert. If the mine should close, there would be no inducement to keep people in the locality, and the city would become merely a group of deserted buildings. Water is so scarce that only a small amount is allowed to each family, and it is delivered in barrels instead of by pipes. Provisions of all kinds are very expensive, for they have to be brought a long distance. The great mine supports the thousands of inhabitants. The varied industries represented there are dependent upon it alone. As long as it pays to mine the copper, the people are as contented as if they were not tucked away in a cañon in a remote corner of the world. The most interesting things to be seen about the city are the mine and the smelter. In the former the ore is obtained. In the latter the ore goes through various processes until it comes out in the form of shining metallic copper. The copper ore, we must understand, is not metallic or native copper, as it is called when found pure, but a combination of copper with other substances which change its appearance entirely. The mine is opened by a shaft, that is, a square hole sunk in the ground. The shaft of this mine is 1,000 feet deep and is being continually extended downward. If we wish to go into the mine, we must put on some old clothes and get the foreman to act as guide. The cage in which we are to descend stands at the mouth of the shaft, suspended by a steel rope. It looks much like the elevators found in city buildings. At different levels, horizontal passages, called drifts, extend to the right and left upon the vein of copper ore. We step out of the car at one of these levels, and with lighted candles start to walk through a portion of the mine. There are so many miles of tunnels that it would take us days to go through all of them. Overhead, under our feet, and upon the sides of the drift, lies the vein of copper, presenting a different appearance at different places. The various ores sparkle in the light, and we gather specimens of each. The common ore is chalcopyrite, a copper sulfide. That is, it is composed of copper and sulfur. It has a brass-yellow color, but is often stained with beautiful iridescent tints. In places the chalcopyrite has been changed to the delicate green carbonate of copper, called malachite. In other places it has given place to the oxide of copper. The little crimson crystals of this mineral give bright metallic reflections. The deposit of copper ore is apparently inexhaustible, for in places the vein widens so that chambers 100 feet wide and several hundred feet long and high have been made in taking it out. In going through the mine we have to be very careful not to step into openings in the floor of the passages, or drop rock fragments into them, for far below miners may be working. The places where the men are taking out the ore are called stopes, and to reach them we have to crawl and creep through all sorts of winding passages, now through a manhole, and now down a long ladder which descends into black depths. From the stopes the ore, as it is blasted out, is shoveled into chutes running down to some drift where there are men with cars. Each car holds about a ton of ore, and after being filled it is pushed along the drift and upon a cage which raises it to the surface. The mine is not wet, for there is so little rain in this region that there are few underground streams. In places, however, it is warm, for when the oxygen of the air reaches the fresh sulfide it begins to oxidize the ore. That is, it begins to burn it, and change it into a different compound, just as fire changes wood or coal. Wherever oxidation is going on, heat is produced. Fresh air is constantly needed in these workings far underground. A supply is forced down in pipes and then allowed to flow back to the surface. In this way a thorough circulation is kept up. Underground one loses all thought of the changes between night and day, for it is always dark there. Consequently, we are surprised on coming up from the mine to find that night has settled over the town. Lights are twinkling everywhere, and miners with their pails of luncheon are coming for the night shift. Another interesting experience now awaits us in the form of a visit to the smelter. Here the bright copper is extracted from the rough-looking ores. How different the two substances appear! They look as if they had scarcely anything in common. The interior of the smelter seems like a bit of the infernal region set upon the earth. While watching what goes on, we might imagine that we were far down in the earth, where Vulcan, the fire god, was at work. At night the scene is particularly weird and impressive, for the shadows and general indistinctness make everything appear strange. The glowing furnaces, the showers of sparks, the roar of the blast furnaces, the suffocating fumes of sulphur, and the half-naked figures of the Mexican workmen, passing to and fro with cloths over their mouths, form altogether a bewildering scene. The ore is first pulverized, and then placed in large revolving cylinders, where it is roasted. A fire is started in the cylinder first, but after the ore becomes so much heated that the sulphur in it begins to burn, no further artificial aid is necessary. Little by little the ore is added in quantities sufficient to keep the fire going. The object of the roasting is to drive off as much sulphur as possible. After being raked from the roasting furnace, the ore is wheeled in barrows to the huge upright furnaces and is thrown in. Here such materials as limestone and iron are also added to aid in the formation of a perfectly fused or molten mass. These substances are known as fluxes. With the melting of the ore, the copper begins to separate from the impurities. The melted ore, in the forms of a glowing liquid, gathers at the bottom of the furnace and runs out into a large kettle-like receptacle. When ore of these vessels is full, it is tipped up, and the molten copper which has collected at the bottom, because it is heavier than the slag, is allowed to run into another large kettle, supported by chains from a rolling truck above. The slag is dumped into a car and is carried outside, while the huge dish containing the copper and some slag is swung to the opposite side of the building, where its contents are cast into another furnace. A very strong blast of air is forced up through the molten mass in this furnace, and the remaining portion of slag is blown out at the top in a shower of glowing particles. From the bottom of the furnace the liquid copper is drawn out and allowed to run into molds where it finally cools. It is then known as copper matte. The copper still contains some impurities and retains in addition whatever gold and silver may have been present in the ore. Most copper ores carry a small amount of these precious metals. The heavy bars of copper matte are now ready for shipment to some manufacturing point, where they are refined still further and made into the various copper utensils, copper wire, and so forth. Copper is valuable for many purposes, as it does not rust easily, is highly malleable and ductile, and is a good conductor of electricity. In the great copper mines upon Lake Superior, copper is found in the native state mixed with the rock, and does not have to be smelted, but in most mines the ore must go through a process very like the one described, before metallic copper can be obtained. It does not matter how remote a region may be, how intense the heat or cold, or how desert-like the surrounding country, men will go to it if minerals of value are discovered, and there they will perhaps spend the whole of their lives, mining these substances which are of such importance to the industries of the world. Chapter 27 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, a Geographical Reader, by Harold Wellman Fairbanks. Chapter 27. Coal and Petroleum. People are beginning to ask where fuel will be obtained when the coal beds are exhausted and the petroleum is all pumped out of the earth. The cold winters will not cease to come regularly, and we shall continue to need fires for many purposes. This is a question which need not trouble us. So long as the sun lasts in the sky and the oceans cover so much of the earth, and so long as there are mountains upon the land, there must be streams with rapids and waterfalls. The power of these streams, which has for ages gone to waste, is now being turned into electricity for purposes of light and heat. We may be sure that long before the mines cease to produce coal and the wells to supply petroleum, there will be something better ready to take their places. But coal and petroleum are still such important commodities that everyone should know something about the way in which they were made. This earth of ours has had a very long history, much of which has been recorded in the rocks beneath our feet, and the record is more accurate than are many human histories which have been preserved in the printed books. The story of the earth has been divided into 4 different periods, each marked by the predominance of certain kinds of living things. The Carboniferous period has been so named because at that time the climate and features of the earth in many places favored the growth of dense and heavy vegetation. This vegetation accumulated through the long years so that it formed thick deposits which gradually changed to beds of coal. It would be wrong, however, to think that all the beds of coal were formed at about the same time. Ever since there have been forests and marshes upon the earth, there have been opportunities for the forming of coal beds. Materials are accumulating even now which will in time be transformed to beds of coal. We must be equally careful to gain correct ideas of the making of petroleum, for many wrong notions are current. While coal has come from the accumulation of plant remains, petroleum has been derived from sea organisms, chiefly animals. If coal and petroleum are found near each other, the occurrence is accidental and does not mean that the 2 substances are in any way related. Our earth is very old, and its surface has gone through many transformations. Mountains, plains, and portions of the seafloor have changed places with one another. Wherever there have been marshy lowlands, since plants first began to grow luxuriantly upon the earth, it has been possible for beds of coal to be formed. We all know how rankly plants grow where there is plenty of heat and moisture. Many of us have been in swampy forests and have seen the masses of rotting tree trunks, limbs, and leaves. Now if we should form a picture in our minds of such a swamp slowly sinking until the water of some lake or ocean had flowed over it and killed the plants, and then washed sand and clay upon the buried forest until it was covered deeply in the earth, we should understand how the coal beds began. Veins of coal that have been opened by the miners frequently show trunks and stumps of trees, as well as impressions of leaves and ferns. Underneath the coal there is usually a bed of clay, while above, sand or sandstone is commonly found. The oldest coal has been changed the most. It is harder and rather difficult to ignite, but when once on fire it gives more heat and burns longer than other coals. This coal, known as anthracite, is not found extensively in the United States outside of Pennsylvania. Coal, which is younger and has been less changed by the heat and pressure brought to bear upon it when it was buried deep in the earth, is known as bituminous. This is the kind of coal which is found in the Mississippi and Ohio valleys, in the Rocky Mountains, and upon the Pacific slope. A still younger coal, which is soft and has a brownish color, is called lignite, and is found mostly in the South and West. Still another sort of fuel, known as peat, is found in swamps where considerable vegetation is now accumulating, or has accumulated in recent times. Peat is a mass of plant stems, roots, and moss, partly decayed and pressed together. In countries where wood is scarce, peat is cut out, dried, and used for fuel. The larger part of the coal in the eastern United States was formed during the Carboniferous period. That part of our country was then low and swampy, but the West, which is now an elevated area of mountains and plateaus, was at that time largely beneath the ocean. Then, as the surface of the earth continued to change, the ocean retreated from the Rocky Mountain region, and extensive marshy lowlands with lakes of fresh and brackish water came into existence. There were such marshes in the areas that are now covered by New Mexico, Colorado, Wyoming, Dakota, and Montana. Westward for some distance the land was higher, but in the states of Washington, Oregon, and California there were other marshy lowlands covered with heavy vegetation. We know from what we have seen in the manner of which wood decays that in the dry open air it does not accumulate, but is in great part carried away by the wind. It is only in swamps and shallow bodies of water that the decaying wood can gather in beds. From these facts we have a right to draw conclusions as to the former nature of the surface where there are no coal beds. There are extensive beds of limestone in the western United States which are of the same age as the coal beds in the East. As such beds of limestone could have formed only in the ocean, their presence throws a good deal of light upon the geography of those distant times. Upon the Pacific slope the marshes were not so extensive, nor did they last for so long a period, as those in the East. Nature seems to have confined her strongest efforts at coal-making to the country east of the Rocky Mountains. Perhaps she thought that the people of the West would not need coal if she gave them plenty of gold and silver. In the Appalachian Mountains, Nature folded the strata and left them in such a position that the coal could be mined easily. In the Mississippi Valley, the beds were left flat, almost in their original position, so that shafts had to be sunk to reach the coal. Upon the Pacific slope Nature seems to have had a large amount of trouble in arranging things satisfactorily. She has made and remade the mountains so many times, and folded and broken the crust of the earth so severely where the swamps stood, that now large portions of the coal beds which once existed have crumbled and been washed away by the streams. The scanty supply of coal which now remains is in most places hard to find and difficult to mine. The best coal, mined near the Pacific, comes from Vancouver Island. Large beds of a younger and poorer coal are found southeast of Puget Sound. There are other beds in the Coast Ranges of western Oregon, and a few small ones in the Coast Ranges of California. The great interior region between the Rocky Mountains and the Coast Ranges has very little coal. The people of California have to import large quantities of coal. Some is brought by the railroads from the Rocky Mountain region, but the most comes by ships from various parts of the world, from England, Australia, or British Columbia. The ships bring the coal at low rates and take away grain and lumber. Coal is almost the only important mineral which Nature has bestowed sparingly upon the Pacific slope. In California, however, she has made amends by storing up large quantities of petroleum. In Pennsylvania and Ohio there is petroleum as well as coal. Oil has also been discovered in the Rocky Mountain region and in Texas. Petroleum is found flowing from the rocks in the form of springs, either by itself or associated with gases and strong-smelling mineral water. The oil is usually obtained by boring wells, but in southern California there is one mountain range which furnishes large quantities through tunnels which have been run into its side. Petroleum is commonly found in porous sandstones or shales. from 100 or 200 to 3,000 feet below the surface. It was not made in these rocks, but has soaked into them just as water soaks into brick. The rocks which produce the oil or petroleum are dark, strong-smelling shales or limestone. Heat a piece of such rock, and you will drive out a little oil. Examine a piece of the shale from one of the oil districts of California, and you will discover that it is a very peculiar rock, for it is made up most wholly of minute organisms which once inhabited the ocean. Among the forms which you will find are the siliceous skeletons of diatoms, the calcareous skeletons of foraminifera, scales of fish, and, rarely, the whole skeleton of a fish. Where now there are mountains and valleys dotted with oil derricks, there was once the water of the open ocean. This water was filled, as the water of the ocean is to-day, with an infinite number of living things. As these creatures died, their bodies sank to the bottom, and while the soft parts dissolved, the hard parts, or skeletons, remained. Through perhaps hundreds of thousands of years, the skeletons continued to accumulate until beds were formed hundreds or even thousands of feet in thickness. The materials of the beds, at first a soft mass, like the ooze which the dredger brings up from the bottom of the present ocean, became packed together in a solid mass. Then disturbances affected this old sea bottom. It was raised, and gravel, clay, and sand from some new shore were washed over the bed of animal remains, burying it deeply. Continued movements of the earth finally folded these rocks, which, as they were squeezed and broken, became warm. The heat and pressure started chemical action in the decayed animal bodies, and particles of organic matter were driven off in the form of oil and gas. These substances were forced here and there through the fissures in the rocks. Part of the products found a way to the surface and formed springs, while other portions collected to form vast reservoirs in such porous rocks as sandstone. The sulphur and mineral springs, which occur in oil regions, tell us that this work of oil-making is still going on. The oil, as it comes from the ground, is usually brownish or greenish in color, and much thicker than the refined product which we use in our lamps. Some of the crude petroleum is thick and tar-like in appearance, and when long exposed to the air turns to a solid black mass called asphaltum. This, when softened by heat and mixed with sand, makes a valuable material for street pavement. End of chapter 27. Chapter 28 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, a Geographical Reader, by Harold Wellman Fairbanks. Chapter 28. The Climate of the Pacific Slope. The western portion of the United States exhibits very interesting climatic features. In California, for example, there may be found every degree of temperature between tropic heat and Arctic cold. In the deserts of the southeastern portion of the state the air is extremely dry, while in the northwest it rains nearly every month in the year. Upon the borders of Puget Sound the thermometer seldom falls below the freezing point, while southern Newfoundland, in the same latitude, is marked by cold and snowy weather for at least 6 months of every year. Southern California has the same latitude as central Georgia, but its average temperature near the coast is but little higher than that of Puget Sound, while it is warmer in winter and cooler in summer than Georgia. The deserts of southern California and Arizona are so hot that for 4 months of the year work in the sun is almost impossible. Yet the higher portions of the Sierra Nevada mountains, but a short distance away, have an Arctic climate. The whole Pacific Coast region has, with the exception of the mountains, a much milder climate than one would expect for a mere knowledge of its latitude. It will be instructive to search out the reasons for the remarkable contrast in climate presented by different portions of the slope. The imaginary lines passing through points of equal temperature upon the earth are called isotherms. These lines rarely accord in direction with the parallels of latitude, but curve far to the north or south. The irregular course of the isotherms is due to many causes. Among these are the distribution of the land and water, the direction of the prevailing wind, the position of the mountain ranges, and the elevation above sea level. In winter the isotherms curve far to the north over the North Pacific and North Atlantic oceans, but over the intervening land they curve as much to the south. In summer the isotherms are almost reversed in position, at least as far as the land is concerned, for they bend to the north in the heart of the continent. There are important reasons for the slight variation of the isothermal lines upon the western borders of North America and Europe, and their great change of position in the interior from winter to summer, but these reasons are not at all difficult to understand. The temperature of large bodies of water changes but little throughout the year, for water warms and cools slowly. The surface of the land, on the contrary, heats rapidly, and then as quickly loses its heat with the changing season. The air over the ocean is cooler in summer and warmer in winter because of the influence of the water, but over the land, in districts far from a large body of water, the changes in temperature between day and night, summer and winter, are very great. It was formerly thought that the warm Japan Current, which flows against the western shore of North America, was responsible for the exceptionally mild climate there, and that the Gulf Stream produced a similar climate upon the coast of western Europe. More careful study, however, has shown that not the warm ocean currents, but rather the winds blowing from the water, are the cause of the mild climate in those lands across which they blow. In temperate latitudes there is a slow movement of the air in an easterly direction, and in consequence the climate of the western coast of North America is not marked by such extremes in winter and summer as are the interior and the eastern sections. It is also surprising to find how nearly alike the average winter and summer temperature is at San Francisco. It is also surprising to note that the average temperature of Seattle differs so little from that of San Diego, although these two places are separated by 16 degrees of latitude. In some places the climatic conditions which we should naturally expect seem to be reversed. Oranges are grown in the Great Valley of California as far north as Red Bluff, and actually ripen a month sooner than they do near Los Angeles, 500 miles farther south. The early ripening of fruits in the Great Valley may be explained by the presence of the enclosing mountain ranges. The Sierra Nevada mountains upon the northeast shut off the cold winds of winter, while the Coast Ranges upon the west break the cool summer winds which come from off the Pacific. Another interesting fact connected with the climate of the West is the influence exerted by the direction of the mountain ranges. As these ranges usually lie across the path of the prevailing winds, their tempering influence is lost much more quickly than it otherwise would be. West of the Coast Ranges the summers are cool and the winters are warm. Upon the eastern side of these mountains the winters are somewhat cooler and the summers very much warmer. In the dry, clear air of the desert valleys, far from the ocean, the daily range in temperature is sometimes as great as 50 degrees, while the winters are cool and the summers unbearably hot. We all know how much cooler a hilltop is than a valley upon a summer day. Where the mountains rise abruptly to a great height, as for example does the San Bernardino Range of southern California, one can stand among stunted plants of an Arctic climate and look down upon orange orchards where frost rarely forms. Mount Tamalpais, a peak of the Coast Range north of San Francisco, has an elevation of nearly 3,000 feet. The summer temperature upon this mountain forms an exception to the general rule, for while the lowlands are buried in chilling fog, the air upon the summit is warm and pleasant. The north and south mountain ranges not only make the interior hotter than it would otherwise be, but rob it of much of the moisture which it should receive. The winter storms coming in from the ocean find the cool mountains lying across their path, and quickly part with a large portion of their moisture. Where the coast mountains are low, as is the case with a great part of California and of Oregon, more of the moisture passes on to the next line of mountains, the Sierra Nevada Cascade Range, the western slope of which is well watered. In the region of the Columbia the Cascade Range is also low, and the storms, which often follow one another in quick succession, sweep across the Columbia Plateau and over the Rocky Mountains. Farther south, not only are the storms fewer in number, but the mountains are very much higher, so that the desert basins of the lower Colorado and Death Valley region are extremely dry. One can in imagination stand upon the summit of the Sierra Nevada mountains, and upon one hand look down upon barren valleys of vast extent, broken by mountains almost as barren, where nothing can be grown except by means of irrigation, and upon the other side, toward the coast, see a country plentifully visited by rain, and either covered with forest or given over to farming and fruit raising. The Rocky Mountains form the eastern barrier which the storms encounter. Their summits are very high and are covered with deep snow during the winter. East of these mountains lie the Great Plains, where the precipitation is light until we go far enough toward the Mississippi Valley to reach the influence of the moist air currents from the Gulf of Mexico. Many storms originate over the region of the Gulf of California, particularly in the late summer, and supplement to some extent the light winter storms of Arizona and New Mexico. The storms of which we have been speaking are known as cyclones. This term does not refer to the local storms which occur in the Mississippi Valley and are frequently so destructive, but to great disturbances of the air. Sometimes the column of whirling air is more than 1,000 miles in diameter. The air in a cyclone is circling and at the same time rising, so that the motion is spiral. If you will study an eddy in a stream of water, you will get an idea of the nature of the motion, except that in the case of the water eddy the movement is downward. The motion of the particles in the dust whirls, which all have been seen moving across the fields near noon on warm summer days, illustrate the movement of the air in one of these great storms. The direction of the air in a cyclone is opposite to that of the hands of a clock. When the winds come up from a southerly point, when high, thin clouds, gradually growing thicken, spread over the sky, and the barometer begins to fall, then it is known that a storm is coming. If one will learn to watch the clouds and the winds carefully, he may become able to predict a storm with almost as much certainty as if he had a barometer. This instrument registers the pressure of the air, which is always less within the area of a storm, because then the air is rising. So when the barometer falls, we may always know that a storm is approaching. The great number of the storms which occur in the central and northern United States come in from the Pacific Ocean in the latitude of Washington. Continuing east or southeast, they reach the Mississippi Valley, and then turn northeastward toward the St. Lawrence Valley. In the summer months there are few storms, and they very rarely reach as far south as California. As winter approaches, the storms become more frequent and severe, and move farther and farther south until the whole land as far as Mexico receives a wetting. Upon the Pacific coast there is often very little warning of the coming of a storm, but in the middle and eastern states they may frequently be predicted several days in advance. With the passing of one of these storms the temperature falls rapidly, and this lowering of temperature, together with the fierce wind, gives rise upon the Great Plains to blizzards or northers. These storms endanger the lives of both men and animals. At different times in the year, particularly in winter, spring, and early summer, warm, dry winds occur. Those winds which sweep down from the heights of the Rocky Mountains and quickly melt the snows are known as Chinooks. The hot north and east winds of California often do great damage to growing crops. Now let us sum up briefly the factors which have together produced the climatic features of the Pacific slope. 1. Ordinarily the factor of the greatest importance is latitude. We should expect that Seattle would have a much colder climate than San Diego because it receives the sun's rays more slantingly. 2. The influence of latitude is greatly modified by the temperate winds blowing from the Pacific, so that places far separated in latitude differ but little in average temperature, their summers being cooler and their winters warmer than we should expect them to be. 3. The storms pass over the land with a general easterly movement of the air. The largest number pass east across the northern portion of the United States. The farther south we go, the fewer are the storms and the less the rainfall. Along the coast of Washington, the annual rainfall is nearly 100 inches. At San Diego, it is only about 10 inches. 4. The position of the mountain ranges causes the influence of the ocean on the air to be lost within a short distance toward the interior of the continent, so that the extremes of temperature rapidly become greater. The position of the mountains also affects the rainfall of the interior. Since a large portion of the moisture is condensed upon their ocean slopes, the climate of each succeeding range toward the interior becomes more dry and desert-like. While in some of the lowlands thus cut off from the ocean the climate is extremely arid, yet the country is relieved from utter barrenness through the presence of mountain peaks and ranges, which often condense considerable moisture. 5. The higher a region is above the sea, the colder the climate. The summit of a high mountain and the valley at its base may be in the same latitude, and yet one may possess an Arctic climate, while the other has a subtropical one. The heavy rainfall in western Washington, Oregon, and northern California results in dense forests. To the south, the rainfall upon the lowlands is not sufficient to produce forests, but as it is greater upon the mountains, trees thrive upon their sides. The elevation at which trees will grow becomes higher and higher as we go into the more desert regions, until in northern Arizona it is found to be above 6,000 feet. The high plateaus are generally treeless, but are covered with such shrubs as greasewood and sagebrush. We see now that our climate is the product of many factors. It frequently varies greatly in places only a few miles distant from each other. Consequently, there may be a great variety of productions and industries in one small area, while in other regions the climate and productions are almost unchanged for hundreds of miles. End of chapter 28. Chapter 29 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, A Geographical Reader, by Harold Wellman Fairbanks. Chapter 29. Something about Irrigation. Travelers from the eastern states who visit New Mexico for the first time are attracted by many unusual sights. There are the interesting little donkeys, the low adobe houses of the native Mexicans, and the water ditches winding through the gardens and fields, which are divided into squares by low ridges of earth. If the fields are seen in the winter time, when dry and barren, the meaning of their checkered appearance is not at first clear, but in the spring and summer one is not long in finding out all about them. When the time comes to sow the seed, water is turned into these squares from the ditches which traverse the valleys, and one square at a time is filled until the ground in each is thoroughly soaked. Afterward, when the ground has dried enough to be easily worked, the crop is put in. The seeds soon sprout under the influence of the warm sun, and the land becomes green with growing plants. The same method of moistening the ground is used for the orchards and vineyards. What is the use of all this work? Why not wait for the rains to come and wet the earth, as the farmer does in the eastern United States? The Mexicans who have tilled these valleys for more than 200 years ought certainly to have learned in all that time how to get the best returns. You may be sure that they would not water the ground in this way if it were not necessary. The fact is that over a large portion of the western half of the United States it does not rain enough to enable the farmer to grow his crops. The climate is generally very different from that of the middle and eastern states. When the Mexicans moved northward into the valley of the Rio Grande River, into Arizona and California, they found a climate similar in many respects to that at home, and soon learned that it was necessary to water the land artificially in order to make it productive. Though in many places sufficient rain fell, yet the heaviest rainfall came in the late summer or winter, when the plants needed it less, while the spring and summer were long and dry. The Mexicans were not the first to practice watering the land, if we may judge from the ruins of ancient ditches constructed by the primitive Indian inhabitants. It is evident that they, too, made use of water in this manner for the growing of their corn and squashes. This turning of water upon the land to make it productive is termed irrigation. The work is performed in different ways, as we shall see later. Irrigation is now carried on through all portions of the United States where the rainfall is light and streams of water are available. To one who has lived in a country where there is plenty of rain, it seems to involve a great deal of work to prepare the land and to conduct water to it. One may feel pity for the farmer who has to support himself in this manner in so barren a country. I am sure, however, that if any such person will stop to think, he will remember times when in his own fertile home the expected rain did not come, and the vegetation wilted and dried up. He may have become discouraged because of a number of dry years, but probably never thought that he had the means at hand to make up, at least in part, for the shortcomings of nature, in sending too much rain one year and another year too little. It would doubtless have paid such a farmer manyfold to have been prepared at the coming of a dry year to turn the water from the neighboring stream over his lands. This process would have involved a good deal of labor, but how the plants would have rejoiced, and how abundantly they would have repaid him for the extra trouble! The showers come without regard to the time when growing things need them most, but with irrigation the crops are independent of the weather. The farmer may be sure that, if he prepares the ground properly, and sows the seed, the returns will be all that he can wish. In many localities several crops may be raised in a year by this method where otherwise only one would grow. Now let us see how the water is taken from the streams, and what are the different methods employed to distribute it over the land. Almost every valley is traversed by a stream, great or small. It may be a river with a large volume of water, or a creek which completely dries up during the long, rainless summers of the West. In rare cases the stream may flow upon a built-up channel which is as high as the valley, but usually it is sunken below the level of the floor of the valley and enclosed by banks of greater or less height. How is the water to be sent over the land? Where the current is swift, you may sometimes see a slowly turning water wheel, having at the ends of the spokes little cups, which dip up the water as the wheel revolves and pour it into a flume that runs back over the land. At some places engines are used to pump the water from the stream and lift it to the desired height. Generally, however, another method is employed. The water is taken out of the stream in an artificial channel dug in the earth. But in order to get the water at a sufficient height to make it flow over the fields, it is necessary to start a ditch or canal at a favorable point some distance up the stream, perhaps miles from the garden. The ditch is made with a slope just sufficient for the water to flow. The slope must be less than that of the river from which the water is taken, so as to carry the stream, at last, high enough to cover the lands to be irrigated. Visit almost any valley in the West where agriculture or fruit growing is being carried on, and you will at once notice the lines of the ditches, apparently level, as they wind around the hillsides. At convenient distances there are gates to let out the water for the orchards and fields. The ground may be moistened in different ways. The first method is that employed by the Mexicans, who, if we except the cliff dwellers, were the first to introduce irrigation into our country. This consists in dividing the land into squares by embankments and allowing the water to flood each in succession. The method is known as irrigation by checks and can be used conveniently only upon nearly level land. In many orchards a series of shallow furrows is plowed between the rows of the trees, and the water is allowed to flow down these until the soil is thoroughly soaked. In alfalfa fields the water is often turned upon the upper end and permitted to work its way across until it reaches the lower edge, soaking the ground as it goes. The slopes must in every case be so gentle that the current will not be strong enough to carry away the soil. Once in every 2 or 4 weeks throughout the spring and summer, the exact period depending upon the rapidity with which the ground dries, the wetting is repeated. If the soil is light, the water must be turned on more often, and a larger supply is required. It frequently happens that the stream from which the water is taken so nearly dries up in the summer, when the water is most needed, that the cultivated land suffers severely. During the winter, little if any irrigation is necessary, but at that time the streams are so full that they frequently run over their banks and do great damage. How to preserve the water thus going to waste and have it at hand for summer use has been an important problem in regions where every particle of water is valuable. Study of the question has led to the examination of the streams with reference to the building of reservoirs to hold back the flood waters. A reservoir may be formed of a natural lake in the mountains in which the stream rises, by placing a dam across its outlet and so making it hold more water. If this cannot be done, a narrow place in the cañon of the stream is selected, above which there is a broad valley. At such a place the dam which is built across the cañon is held firmly in place by the walls of rock upon each side, and an artificial lake or reservoir is made. Ditches lead away from this reservoir, and by means of gates the water is supplied when and where it is needed. The streams which furnish the water for irrigation in the arid region rise in mountains with steep rocky slopes, and until the water issues from these mountains it is confined to cañons with bottoms of solid rock, so that no water is lost except by evaporation. After the streams emerge from the cañons upon the long, gentle slopes of gravel and soil which lie all about the bases of the mountains, they begin immediately to sink into the porous material. They frequently disappear entirely before they have flowed many miles. Some of this water can be brought to the surface again by digging wells and constructing pumping plants, but the greater part is lost to the thirsty land. To prevent the water from sinking into the gravel, ditches lined with cement are often made to carry it from the cañons to the points where it is needed. Sometimes iron pipes or wooden flumes are used in places of the ditches. What a transformation irrigation makes in the dry and desert-like valleys of the West! Land which under nature's treatment supports only a scanty growth of sagebrush or greasewood, and over which a few half-starved cattle have roamed, becomes, when irrigated, covered with green fields and neat homes, while sleek, well-fed herds graze upon the rich alfalfa. 10 acres of irrigated land will in many places support a family, where without irrigation a square mile would not have sufficed. One might suppose that the soil of these naturally barren valleys was poor, but such is not the case. The ground did not lack plant food, but merely the water to make this food available. With plenty of water the most luxuriant vegetation is produced. The soil is, indeed, frequently richer than in well-watered regions, for a lavish supply of water carries away a portion of the plant food. In some places, where the land is almost level and the soil is filled with large quantities of soluble materials, such as soda and salt, Keeping the ground moist through the irrigation brings these substances to the surface in such quantities as to injure and sometimes kill the vegetation. In order that such lands may be successfully cultivated, the salts have to be either neutralized or washed away. Many of the rivers of the West carry large quantities of silt in suspension, which fills the ditches and causes a great deal of trouble. But when the silt is deposited over the surface, it adds continually to the richness of the land. The full development of irrigation will mean a great increase in the population and wealth of all the Western states. End of chapter 29. Chapter 30 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, A Geographical Reader, by Harold Wellman Fairbanks. Chapter 30. The Location of the Cities of the Pacific Slope. This old earth has to be consulted upon every occasion. It is a silent partner in all our undertakings. We sometimes think that we come and go as we please, but a little thought convinces us that we are not really so free. The traveler must take account of the slopes of the land. It is much easier for him to follow a valley and cross a mountain range through a low spot, although his course be very crooked, than it is to make a bee line for his destination. The farmer, in choosing his home and the kind of produce which he will raise, has to consult the soil and climate. He cannot expect to grow grain where the soil is poor and dry, or grow apples where the late spring frosts kill the buds. The miner knows that he cannot expect to find gold veins in the valleys, where the rocks are deeply covered by the soil, and so he turns his steps towards the mountains, where nature has made his work easy by lifting up the rocks and exposing them to his view. Routes of commerce and trade are governed by geographic and to a certain extent by climatic conditions. Shallow streams with rapids and waterfalls obstruct navigation. The absence of harbors along a given coast makes it difficult for ships to take and discharge cargoes. Railroads cannot be constructed unless long and expensive surveys have first been made to determine the route which nature has made the easiest between the two given points. The character of the climate and geographic features of a given country determine whether it shall become noted for agricultural productions, mining industries, manufactures, or commerce. The locations of the cities and towns and the roads connecting them depend upon geographic conditions. There is not an occupation of any importance in which people engage at any particular place that is not dependent in a large degree for its success upon the conditions which nature has imposed upon that place. A city will not grow up at a given point unless the geographic conditions are favorable. There must be some natural reason to induce people to gather in large numbers in one place. At one spot there are facilities for manufacturing, such as water power and coal, and easy means of communication with other parts of the world. At another, the only reason for the growth of a city is the existence of rich mines. A third place may be conveniently located in the midst of a rich agricultural region, where it is easy to bring in supplies and ship out the products of the soil. A study of the founding and growth of some of the cities of the West, and particularly the Pacific Slope, will bring out many interesting facts. San Francisco is the metropolis of the Pacific. Its population will soon reach 500,000. If we look back 75 years, we find San Francisco an unimportant Mexican military post and the seat of one of the smaller missions. Monterey, the capital of the province of California and one of the two leading towns, Los Angeles being the other, apparently had all the advantages in the race for supremacy. In date of discovery, 1603, Monterey Bay has the advantage of more than 150 years over San Francisco Bay. It is difficult to understand why the different navigators who sailed north along the coast failed to discover California's most magnificent bay. Sir Francis Drake went by it, evidently not seeing the narrow opening between the headlands now known as the Golden Gate. Vizcaino, after discovering Monterey Bay, also passed by and anchored where Drake had stopped, in a little bay now called Drake's Bay, a few miles north of San Francisco Bay. After the founding of San Diego in 1769, a party started overland for Monterey, but by reason of the peculiar position of the bay they passed it unknowingly, and by accident came upon the body of water which has since been of so great importance to the commercial life of California. Monterey Bay, in time, lost its importance, partly because it was not thoroughly protected from the storms, and partly from the lack of easy communication with the rest of the state. Immediately after the acquisition of California and the discovery of gold, the advantages of San Francisco Bay began to be appreciated, and the little Mexican town grew rapidly. The narrow entrance to the bay, which had for so long a time delayed its discovery, completely protected it from the storms, while its long arms opened across the coast mountains directly into the important valleys of the interior. Ocean vessels could go up and down the bay and through the Strait of Carquinez, while river boats could be used for many miles farther. After the discovery of gold, ships from all parts of the world found ample room and shelter in San Francisco Bay, and the incoming miners, going by the water routes to Marysville, Sacramento, and Stockton, easily reached the gold-bearing gravels of the Sierra Nevada streams. With the exception of southern California and a portion of the northern coast, almost all the agricultural and mineral resources of California are directly tributary to San Francisco. This place is naturally the center of home trade, of foreign commerce, and of population. Nature failed to supply San Francisco with one essential advantage, namely, cheap power for manufacturing. There is no water power near and but little coal in the state. Since the coal has to be shipped in from distant points, its high price has impeded manufacturing. But now it appears that San Francisco is not so badly off after all, for important deposits of petroleum have been discovered in the central and southern portions of California, and besides, processes have been invented for transforming the unlimited water power of the mountain streams into electric energy, and transmitting this power to all the cities about the bay. The early Spaniards founded the pueblo of Los Angeles in its present location, because at this point the Los Angeles River carried an abundance of pure water which could be let out in ditches to irrigate the fertile bottom lands in the vicinity. Partly because it became a railroad center, and partly because it is surrounded by rich valleys, Los Angeles has grown with great rapidity and now stands next to San Francisco in size among California cities. San Diego, which has a harbor next in importance to that of San Francisco, has grown more slowly, because of the greater difficulty in developing water systems for irrigation, and because access is not so easy on account of the enclosing mountains. However, it must in time become the second commercial city of the state. Mountain barriers make travel from one portion of California to another somewhat difficult. Mountains separate San Francisco and the Great Valley of California from all other portions of the continent. Nature seems to have planned here a little empire all by itself. But engineering skill in the construction of railroads has overcome the barriers upon the north which separates California from Oregon. The Sierra Nevada range upon the east has been crossed at Donner Pass, and upon the south an outlet has been found through the Tehachapi Pass. In the state of Oregon, the city of Portland ranks first in importance. Why did not Astoria or Fort Vancouver develop into the metropolis of the Columbia Basin? Astoria, which was founded in the early part of the last century, has a spacious and well-protected harbor, but it has no large tributary agricultural valleys. Moreover, the greater number of deep-water ships pass it by, and go as far up the Columbia as possible to take on their loads of grain. Fort Vancouver, on the site of the old Hudson Bay trading post, is practically at the head of deep-water navigation upon the Columbia, but there seems to be no particular reason why trade should center here, and this town also has been left behind in the march of progress. The earliest settlements in western Oregon were made upon the Willamette River, which drains a large and extremely fertile valley. Near the point at which this river joins the Columbia, the city of Portland sprang up. This town occupies an ideal position. It is accessible for deep-sea vessels and has communication by river boats with the Willamette Valley and the upper Columbia River. In the 18th century, when sailors were looking for a passage across the northern portion of the continent, an opening was found extending into the land between Vancouver Island and Cape Flattery. It was at first thought that this was the desired waterway, but various navigators, among them Vancouver, explored the body of water into which the Strait of Fuca opened, only to find that every branch and inlet terminated in the land. Puget Sound is nearly enclosed by water, and is so large as really to form an inland sea. Its long arms reach out in three directions among the most heavily timbered valleys and mountain slopes of the United States. The cities of Puget Sound had a later start than most of the other cities of the Pacific coast, for this portion of the old Oregon Territory was for a long time claimed by the English, and during that period was peopled only by Indians and trappers. In 1846 the present boundary was established, and Puget Sound passed into the possession of the United States. Because of the dense forest, agriculture could not play an important part in the development of the Sound region for some time. Lumbering was naturally the leading occupation. This industry could be carried on all the more advantageously because of the innumerable inlets penetrating the land. The advantages of Puget Sound for foreign commerce began to be evident, but the Cascade Range stood in the way of railroads from the eastward. Although it was a comparatively easy task to build a railroad north from Portland, yet the Sound region did not begin to grow rapidly until, after careful surveys, two railroads finally found passes through the Cascade Range so as to reach tidewater. As in other places, when the necessity for overcoming them arose, the obstacles which nature had interposed were not found to be so troublesome as was at first supposed. Now the once formidable range has been tunneled and will no longer form a serious barrier between the interior portion of Washington and the coast. Tacoma, Seattle, and Everett have grown up on the Sound as important commercial and manufacturing cities, and will, on account of their favorable situation, receive their share of the commerce of the Pacific. The cities of the Sound are particularly well situated for intercourse and commerce with Alaska and northeastern Asia. These cities are also well situated for manufacturing, because coal and wood are plentiful and consequently cheap, but they have not in their immediate vicinity so extensive agriculture valleys as the Willamette and the Great Valley of California. The lumberman must be supplanted by the farmer and fruit grower before the slopes about the Puget Sound can be fully developed. The natural outlet for the great wheat fields of central Washington is by way of the Columbia River to the ocean, but the tunneling of the Cascades partly diverts their products to the Sound region. The city of Spokane, in eastern Washington, clearly illustrates the control which physical features exert upon the settlements and industries of men. The Spokane River, soon after issuing from C. and Oleg Urdaline Lake, flows out over the volcanic plains of Washington. In the course of a few miles it descends into a shallow cañon by a series of cascades and waterfalls. The water power furnished by these falls has determined the position and growth of Spokane. The falls brought sawmills and manufacturing plants, and these in turn brought people and railroads. The city has become a great commercial center for all the region round about. The extensive and rich mineral district upon the north, extending even into British Columbia, finds its most convenient source of supplies at Spokane. East of the city is the C and Oleg or Dalene mining region, while south and west are large areas devoted to the cultivation of fruit and grain. The city of Great Falls, Montana, in the Missouri River basin, is destined to become a great industrial center, because of the presence of unlimited water power afforded by the great falls of the Missouri River. No other reason would lead to the growth of a settlement at this particular spot, for boundless plains extend about in every direction. The mining cities of the West, such as Butte, Virginia City, and Leadville, illustrate the growth of important centers of population in the vicinity of large deposits of minerals. In the case of these cities, as well as many others, there are no agricultural resources in the surrounding country to support the people gathered together here. Nearly all their food has to be shipped hundreds of miles. Cities supported by mining are less likely to be permanent than those supported by an agricultural community, by commerce, or by manufacturing. End of chapter 30. Chapter 31 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, a Geographical Reader, by Harold Wellman Fairbanks. Chapter 31. The Forest Belt of the Sierra Nevada Mountains. No other coniferous forest in the world can compare with those covering the western slope of the Sierra Nevada and Cascade Ranges. They are remarkable both for the number of species and for the size of the trees. The moderate temperature and the moist winds from the Pacific seem to offer the conditions which are best suited to the growth of cone-bearing trees. As we go northward along the coast or ascend the mountain slopes, we find the climate growing cooler and cooler. With this changing climate the species of conifers change, for each has become accustomed to certain conditions of temperature and moisture, which it must have in order to thrive. The Sierra Nevada is the most continuous lofty range of mountains in North America. From the Great Valley at its western base to the crest of the range the distance is about 60 miles. Because of the great height of the mountains, there is found within these few miles every variety of climate, between the subtropical atmosphere of the valley, where oranges ripen to perfection, and the Arctic cold of the summits, where little or no vegetation can live. Thus, by climbing a single mountain range, we may experience all kinds of climate, and have an opportunity to observe the different forms of plant life, such as we would not otherwise obtain without a journey of several thousand miles. Passing through the groves of valley oak, and beyond the orange orchards at the foot of the mountains, we reach the foothills and begin to ascend. Several species of oak are found upon the hillsides and in the valleys, while mingled with them in many places appear such shrubs as the California lilac, chamiso, and manzanita. Where the soil is too poor or the slopes too steep for the trees, these shrubs, commonly called chaparral, are massed together in almost impenetrable thickets. The first of the coniferous trees which we meet is an odd-looking one known as the digger pine. Instead of having a single straight trunk, it divides a short distance above the ground into many branches. The large cones are armed with long hooked spines, so that they must be handled rather carefully, but when opened they are found to be filled with nutritious nuts. These nuts were an important source of food for the Indians who once inhabited the foothills. Now the Indians are gone, but the nuts are not wasted, if one may judge by the fragments of the cones with which the squirrels strew the ground. The road climbs the foothills by many turns and windings through the cañons, and up and down ridges. At an elevation of about 2,000 feet specimens of the yellow pine appear. The trees increase in size and grow more closely together as we ascend. We soon find ourselves in the edge of the forest belt which extends unbroken northward to the Arctic zone, and upward to the line of almost perpetual snow. The yellow pine, so named from the color of the bark, sometimes attains a diameter of 6 feet, but does not form so dense forests as we shall find higher on the mountains. The rays of the warm sun, reaching down between the trees to the carpet of needles and bear clover, draw out their spicy fragrance. The yellow pine, although it does not afford as good a quality of lumber as some of the other pines, is one of our most important trees because of its wide distribution through nearly all mountains of the West. It has a much wider range in elevation than most trees, one variety reaching upward nearly to the timber line. After getting well into the yellow pine forest, we soon come upon other trees that contend with the pines for a footing upon the slopes and for a bit of the sunshine. Among these, the black oaks deserve special mention, for in places they form dense groves upon the ridges. The cedars with their rich brown bark and flat, drooping branches are easily recognized. As these trees grow old, they become gnarled and knotty and very picturesque. We first meet that king of pines, the sugar pine, upon the more shaded mountain slopes. Although higher up on barren, rocky ridges, this tree grows to noble size, yet it cannot withstand heat and dryness. Our attention may be first called to the sugar pine by the slender cones, 10 to 15 inches in length, which are scattered over the ground. Then, as we look up to see whence the cones come, our eyes light upon the smooth trunks, often over 6 feet in diameter and reaching up 150 feet before the branches appear. From the ends of the long, drooping branches hang slender green cones. The name of this pine is derived from the fact that a white sugar gathers in little bunches at the spots where the trunk has been injured. This sugar is pleasant to the taste and somewhat medicinal. The wood of the sugar pine, which is white and fine-grained, is of greater value commercially than that of any of the other pines. This fact leads the shake maker and lumberman to seek out the noble tree and mark it for destruction. The sugar pine, when once destroyed in a given locality, rarely replaces itself, as it is crowded out by the more vigorous conifers. Scattered through the forest of yellow pine, cedar, and sugar pine is the Douglas spruce, commonly known in the market as the Oregon pine. This is the most important forest tree in Oregon and Washington. It often grows to a height of 300 feet, and forms dense forest for hundreds of miles along the base of the western slope of the Cascade Range. In Washington it is found growing down to the sea level, but in the Sierra Nevada the requisite moisture for its growth is not found much below an elevation of 4,000 feet. As we go upward the pines become fewer and the firs and big trees take their places. The big trees are found in scattered groves, at an elevation of 5,000 to 8,000 feet, for a distance of 250 miles along the slopes of the Sierra Nevada mountains. The sequoia, as the genus is called, which also includes the redwood of the Coast Ranges, is in many respects the most remarkable of all our coniferous trees. After traveling through the forest made up of other trees of great size, it is difficult at first to appreciate the magnitude of the big trees. Rising from a swelling base, which is sometimes 30 feet in diameter, the symmetrical trunk reaches up and up, finally terminating in a top 300 to 350 feet above the ground. Their size, their reddish-brown bark, and their small cones clearly distinguish these trees. Great holes have been burned in many of them, and in the hollows thus formed men have made for themselves comfortable living rooms. In one of the southern groves a fallen hollow tree has been used as a cabin. The big trees and redwoods are the last surviving species of a genus which was once widely distributed over the earth. The ancestry of the sequoia can be traced farther back than that of any of the other living conifers. Impressions of cones and small stems with needles attached belonging to the sequoia have been found in the oldest rocks of the Coast Ranges of California. These cones and stems were washed into some muddy estuary and there buried, millions of years ago. The mud enclosing them was compressed and hardened, and finally changed to slate. This was at last exposed upon the surface through the uplifting of a mountain range and the work of erosion. Some of the groves of the Big Trees have been included in government parks and reservations, but others are being cut as rapidly as possible by the lumbermen. The redwood of the Coast Ranges is not easily killed, for it sprouts from the stump, and will in the course of time form forest again. But the Big Trees rarely replace themselves when a grove has been cut down. These trees are so few in number and of such remarkable interest that they should be spared the fate of the common forest tree. It would make you feel sad to visit one of the groves and see, as I did, a fallen giant, fully 30 feet in diameter, lying split open upon the ground. This tree was so large that in order that it might be handled at all, powder had to be used to blast it in pieces. The tree was knotty, and according to the lumbermen of little value, and might as well have been left. What excuse is there for the wanton destruction of a noble tree like this one? It must have stood from 5,000 to 6,000 years. It was a mighty tree at the beginning of the Christian era, and was growing a strong tree when our ancestors were the rudest savages of the wilds of Europe. But we must not remain among the Big Trees, for the forests extend much farther up the mountains. The most important tree of the upper forest belt is the fir, which is found growing from 5,000 to nearly 9,000 feet above sea level. It is one of the most graceful of the conifers. Sometimes these trees reach a height of 250 feet and form dense forest with little undergrowth. The branches make the soft, fragrant beds which so rest and delight the tired mountain climber. Here and there about the springs and at the heads of the streamlets the firs appear to stand back, making room for green meadows brightened with a profusion of flowers. The tamarack, or lodgepole pine, is sometimes found at about the same elevation as the first, but seems to prefer the moist lands about the meadows and the bottoms of the narrow valleys. This tree is widely distributed at high altitudes all over our western mountains. Continuing our climb toward the alpine regions, we reach an elevation where the trees begin to show the effects of the winter storms. The fact that life is not so easy as it is farther down the slopes is apparent from the gnarled and stunted trunks. Here are the alpine hemlocks, dwarf pines, and junipers. The juniper somewhat resembles the cedar, but has a short, thick trunk. Near the timber line, this tree grows but a few feet high and becomes exceedingly gnarled. It seems to like the most exposed and rocky places, but in truth, like many another form of plant life, it has become accustomed to such locations because it cannot successfully compete with other trees in happier ones. Most weird and picturesque of all are the dwarf white pines, growing upon the extensive mountain shoulders and ridges at a height of 10,000 to 11,500 feet above the sea. Since an Arctic climate surrounds them for 9 months of the year, their growth is very slow. Their short, gnarled trunks and branches are twisted into all sorts of fantastic shapes. When, after struggling with the cold and the storms, the trees at last die, they do not quickly decay and fall, but continue to stand for many years. These trees become smaller and smaller in size, until at the extreme timber line they are almost prostrate upon the ground. In many cases they rise only 3 or 4 feet and have the appearance of shrubs rather than trees. Still above them, however, there are rocky slopes and snowbanks reaching to an elevation of over 14,000 feet. If we examine these upper slopes carefully, we shall find that they are not utterly devoid of life, but that certain plants have been able to obtain a foothold upon them. In sheltered nooks there are little shrubs and lichens. In some places among the rocks, beneath overhanging snowbanks, beautiful flowers spring up at the coming of the late summer, blossom, mature their seeds, and die with the return of the winter cold. The magnificent forest through which we have passed in our long climb, if destroyed by the lumbermen, cannot be replaced for hundreds of years. They contribute much to the glory of the mountains. They hold back the water so that it does not run off rapidly, and thus aid in giving rise to innumerable clear, cold springs. The springs help feed the streams during the long, dry summers, when the water is so sorely needed in the hot valleys below. End of chapter 31. Chapter 32 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, a Geographical Reader, by Harold Wellman Fairbanks. Chapter 32. The National Parks and Forest Reserves. The people who first pushed into the unknown country west of the Mississippi in the earlier half of the last century were chiefly hunters and trappers. They did not intend to make permanent homes in the wilds, but rather to stay only so long as they could secure an abundance of fur-bearing animals. Then came the discovery of the precious metals, and thousands of gold-seekers crossed the plains, and spread out over the mountains of the Cordilleran region. They, too, expected to get rich by making use of the resources of the country, and return to their homes in the East. At the present time, the destruction of our forests and serious injury to the water supply has been threatened through the organization of large lumber companies. Those interested in lumbering usually live far removed from the scenes of their operations, and consequently care little about the condition in which the deforested lands are left. The farmers were the first permanent occupants of the West. Unlike the wandering trappers and miners, they established homes and made the land richer instead of poorer. As long as the population was scanty, there was not much danger of exterminating the wild animals, and the demands for timber were small. Our forefathers who settled the eastern states had to contend with the forest. Nearly every acre of ground had to be laboriously cleared before anything could be planted. It was only natural that they should come to regard the forest as a hindrance rather than a blessing. As the settlers spread westward to the prairies and plains, they came upon a region almost destitute of forests, but still farther, in the mountains of the Continental Divide and the Pacific Slope, they again found extensive forest. To them it seemed impossible that these forests could ever be exhausted, and therefore little care was taken for their preservation. As the population increased, more and more lumber was needed for building purposes. Before the sawmill came, split lumber was used, and the shaker maker did not hesitate to cut down the largest and most valuable pines on the mere possibility that 15 or 20 feet of the butt would split well enough to make shakes. It made no difference to him that the whole trunk rotted upon the ground. When the sawmills were built, and there came a demand from abroad for lumber, the forests were attacked upon a much larger scale. The need of the moment was all that concerned the lumbermen, and they took no care for the preservation of the young trees, which in time would have renewed the supply. The litter of the trunks and branches which they left upon the ground furnished fuel for the fires which frequently swept over these areas and killed the remaining growth. As a result of these fires, the few animals that have escaped the hunters have been killed or driven from their homes, and the forest cover, which would retain much of the moisture and preserve it for the supply of the streams in summer, has been destroyed. The removal of the forest cover leads also to the washing away of the soil, the shoaling of the streams, floods in spring, and low water in summer. In fact, all the people and industries of the region are affected by its loss. It may take hundreds of years for the country to recover. Indeed, if the rainfall is light, the forest may never grow again, without artificial aid. Seeking to enlarge his pastures by burning the underbrush, sets fires which often destroy hundreds of square miles of forest. The summer camper and the prospector also frequently go on their way without extinguishing the campfire, though a great forest fire may be the result. Ours is a fertile and productive earth, capable of supporting a multitude of living things. For ages the lower animals, as well as savage man, lived under the protection of Nature, making the best use of her products of which they were capable, but they never brought about the unnecessary and often wanton destruction of which we are guilty, we who call ourselves civilized. In killing the wild animals we cannot make the plea of necessity, as can savages who have no other means of support. Likewise, there is no necessity for killing the beautiful singing birds, merely for their plumage. The forests are cut away without any thought of the retribution which Nature is sure to bring upon us. They are of vast importance to the well-being of the country and are the natural possession of all its people. We ought not to permit them to be destroyed indiscriminately for the benefit of a few. We need lumber for many purposes, but a careful treatment of the forest, with an eye to their continuance, the plan of cutting large trees and preserving the small ones, is a very different thing from our present wasteful methods. Every summer the air is filled with the smoke of burning forest, and the lumbermen are at work harder than ever felling virgin forest upon more and more remote mountain slopes. Books of travel, written 50 years ago, tell of animal life in such abundance in many portions of the West that we can hardly believe their stories. A description of California written in 1848 mentions elk, antelope, and deer as abundant in the Great Valley. How many of us living at the present time have ever seen one of these animals in its native haunts? There is hope now that this wasteful use of Nature's gift will soon be stopped. Large areas of the mountainous portions of the public domain are being set aside as parks and forest reserves. The parks contain some of the finest scenery and most wonderful natural curiosities to be found upon the face of the whole earth. This wild scenery, together with the forests and plants of every kind, as well as the animals and birds that inhabit these areas, are to remain just as they were when the first white man looked upon them. The parks form asylums for the wild creatures which have been hard pressed for so many years. In the Yellowstone National Park, where they have been protected the longest, the animals have lost their fear of man and act as if they knew that they are safe within its limits. In the Yellowstone you may see great herds of elk feeding in the rich meadows. Deer stand by the roadside and watch you pass, while the bears have become so tame about the hotels that they make themselves a nuisance. 16 bears at a time have been seen feeding at the garbage pile near the Grand Cañon Hotel. The forest reserves differ from the parks in that they are established for utility rather than for pleasure. The forests now existing are to be cared for by the government and to be wisely used when lumber is needed. Fires are to be avoided so far as possible, and burned areas are to be replanted with trees. Another object to be accomplished is the restitution of the forest about the heads of the streams so as to preserve the summer water supply. Another object to be accomplished is the retention of the forest about the heads of the streams so as to preserve the summer water supply. The water runs off more slowly from a slope covered with vegetation than from a barren one, and therefore has more time to soak into the ground. This is a very important matter in all mountainous districts, particularly where the rainfall is light. The Yellowstone National Park is situated upon the Continental Divide in northwestern Wyoming. It is largely a plateau, with an elevation of 7,000 to 8,000 feet above the level of the sea. The surface of the plateau is covered with forest, meadows, and lakes, but the region is particularly remarkable for the geysers and hot springs, and the Grand Cañon and falls of the Yellowstone River. Springs dot the surface of many parts of the park. The hot water is continually bringing mineral substances, the chief of which is silica, from the depths of the earth and depositing them about the orifices of the springs. In this manner wonderful basins, terraces, and cones have been built up, while the rocks have been either reddened or bleached out and softened into a form of clay. The park region must have been for a long period the seat of volcanic action, for nearly all of the rocks are cooled lavas. While the heat has disappeared from the surface, it must still be very great below if we may judge by the quantities of hot water continually issuing from the springs. In many a subterranean cavern, steam accumulates until its pressure becomes too great for the column of water occupying the channel that leads to the surface. Then the water is suddenly and forcibly expelled, giving rise to a geyser eruption. When the pressure of the steam has been exhausted, the water sinks back into the earth, leaving the basin of the geyser nearly or quite empty until the steam has again collected. Each geyser has its own period of eruption and is generally very regular. One little geyser, known as the Economic, because it throws out but little water, spouts regularly about every 5 minutes. Other geysers are active at intervals of several hours, while some take several years to get ready for a new eruption and then spout whole rivers of boiling water. In the upper geyser basin the effect is very impressive, particularly upon a cool morning. The clouds of steam and the throbbing or roaring geysers lend to the region a weird and unearthly aspect. The Yellowstone Lake is a large body of water situated almost upon the continental divide. Before the cañon or Great Falls, or even the Yellowstone River itself existed, the lake stood about 150 feet higher than at present, and its water emptied into the Pacific Ocean instead of the Gulf of Mexico. The drainage was changed by the work of a small stream, having its source in the volcanic plateau north of the lake. It deepened its channel, and extended its headwaters back until they tapped the lake at a point where the rim of the basin was lowest, and so drew away its waters in the opposite direction. The Yellowstone River, with its deep, wondrously colored cañon and grand waterfalls, is the result of this change. To the south of Yellowstone Park, but included in one of the forest reserves, are Jackson Lake and the Teton Range. The three Tetons, one of which reaches a height of over 13,000 feet, were evidently noted landmarks for the hunters and trappers in the early days, for you will find them mentioned in many of the narratives of those times. The precipitous range, with its crown of jagged peaks and the beautiful lake nestling at its base, presents a picture never to be forgotten. Very different from the region which we have been studying is that embracing the Crater Lake National Park, which is situated upon the summit of the Cascade Range in southern Oregon. Here occurred, not many thousand years ago, one of the strangest catastrophes which, so far as we know, has ever overtaken any portion of our earth. Towering over the present basin of Crater Lake was a great volcano, reaching probably nearly 3 miles toward the sky. During the glacial period it stood there, its slopes white with snow, apparently as strong and firm as Shasta or Hood or Rainier. But for some reason the volcanic forces within this mountain, which has been called Mazama, awoke to renewed action. The interior of the mountain was melted, and the whole mass, unable to stand longer, fell in and was engulfed in the fiery, seething lava. This lava, instead of welling up and filling the crater and perhaps flowing out, was drawn down through the throat of the volcano into the earth, and left an enormous pit or crater where once the mountain stood. After the floor of the crater cooled and hardened, small eruptions occurred within it and a new volcano grew up. But though nearly 3,000 feet high, it does not reach to the top of the encircling walls of the old crater, which are on an average nearly 4,000 feet high. Then the rains and melting snows formed a body of water in the crater, and the wonderful lake came into existence. No such sight is to be found elsewhere upon the earth. Within a circling rim of cliffs, from 800 to 2,000 feet high and nearly vertical, lies the lake, rivaling the sky in the depth of its blue coloring. The height of its encircling cliffs and its 5-mile expanse of blue water help to make the lake a spectacle grand beyond description. At the present time the volcanic fires appear to be entirely extinct. Forests of fir and tamarack have spread over the once barren slopes of lava and pumice which extend back from the cliffs. In the hollows, after the lingering winter snows have melted, there are grassy meadows dotted with flowers. It is many miles from the lake to any human habitation, and all the region about remains just as Nature left it. It was a happy thought to make another national park here. We have already learned something of the grandeur of the Yosemite Valley and have seen how it came into existence. The valley is owned and cared for as a public park by the state of California, but, with Hetch Hetchy Valley, it is included in a larger park under the control of the general government. Within the boundaries of this national park, as in the case of the others described, the natural features of the landscape, the forest, and the animals are to be left forever undisturbed. The Yosemite Valley, although situated in the heart of the rugged Sierras, is reached by several good wagon roads, and many more people visit it than go to Crater Lake, though the latter is fully as interesting. About 100 miles south of the Yosemite is the General Grant National Park. This park is of comparatively small size, but contains a group of some of the largest and finest big trees in the country. Still farther south there is a reserve called the Sequoia Park, which contains the largest remaining groves of the big trees. There are also many state parks scattered over different parts of the Union. The establishment of these parks is intended to preserve either the forest or natural scenery. The retention by the state or general government of large tracts of mountain and timberland, and of those areas which are particularly interesting on account of their natural scenery, is of the greatest importance. The timber and water are preserved for the general good instead of being squandered for the enrichment of individuals. The preservation of scenic features in their original wild state is just and right, because such things add to the pleasure of out-of-door life, elevate men's feelings, and cultivate a love for the beautiful. The protection afforded the plant and animal life by these reserves gives a better opportunity for studying them, and tends to foster a general interest in the welfare of living things. End of chapter 32. End of The Western United States, a Geographical Reader, by Harold Wellman Fairbanks.